So here's our first question for today. And our first question for today is asking us, what is the 45, 90 degrees triangle rule? I guess not many people call it that way. Most people just call it special triangles. We have two special triangles in trigonometry, and one of them is 45, 90 degrees. So let me just draw this triangle. So here we have the 90 degrees angle for our triangle, and for the other two angles, they're each 45 degrees. And this is one of our special triangles. So here is our 45, 90 degrees special triangle for trigonometry. Special triangle. And this is an isosceles triangle because it has two equal angles, and the third angle is 90 degrees. The other thing to note is that the hypotenuse of this triangle is √2, and the two sides of these triangles has length 1. So this special triangle is really useful if you want to find the sine of pi/4, or the cos of pi/4, or the tan of pi/4, or like the cotangent, cosecant, secant of pi/4, etc. So this is a really handy triangle, and it's one of the two special triangles in trigonometry. All right, now let's look at the sample solution here. Yes, they just mentioned it's one of the two types of special triangles. Yes, they talk about the ratios of the sides. Okay, let's just say, great explanation, great job, the solution is correct. The solution is correct. And now let's move on to our next problem. So here's our second problem, and it's asking us, why is the cosine of 0 equal to 1? Well, there are multiple answers. There are multiple ways to approach this problem. First, you can approach it from the function point of view. So when you have the function y equals cos of x, so you have f of x, or y is equals to cos of x. And the function goes like this, and forever, and repeats in oscillations. So this is, we have y-axis, and here we have the x-axis. At the point x equals to 0, so at x equals to 0, which is this point where x equals to 0, the y value of the function is 1. F of 0, or I guess I should say y value, our y value is equals to f of 0 is equal to cos of 0 is equal to 1. And that is part of the reason of why the cosine of 0 is equal to 1. The other reason is that the cosine function is derived from the unit circle. So we know that on the unit circle, the x values is the cos values, and the y values is our sine values. So here we have 1, 0. Here we have 0, 1. Here we have -1, 0. And here we have 0, -1. And here's our unit circle. I'm going to try my best to draw a roundish circle. It doesn't quite work out, but pretend this is a round circle, or this is a regular circle. So it's not always just a regular circle that has radius 1. So this is our unit circle here, and we know that for the unit circle, the x values are the cosine values, and the y values have the same value as the sine values. So at angle 0, which is cos of 0, so at angle 0, here, let me just write down the unit circle. Unit circle. And let me put a line through here, so to make sure that you know that these are two different, or I guess they're kind of related because they're all, but let me just put a line through it. Okay, so here we know that for our unit circle, at the angle equals to 0 degrees or 0 radians, the x value, we have the x value is equal to 1, which is equal to cos of 0. And this is another reason that our cosine values is, our cos of 0 is 1, okay? So here, let me look at the sample solution. It just says that at angle theta or at angle 0, the adjacent hypotenuse are equal. So the value of, no, I'm not sure if, okay, let's just say try to provide a more in-depth or okay, let's just say either try to provide a more an explanation in terms of the sine function or unit circle, or add sentences illustrating why the sine of 0 is not 1, because the sine of 0 is 0. Okay, so let's just say the solution is incorrect and move on to our next problem. Okay, the next problem here is asking us what are like fractions. So basically, fractions, so let's first talk about fractions quickly. Fractions have a numerator, which is a number on top, the numerator, and a denominator. And it basically, it just means that in this specific case, we have 2 over 7. The numerator is 2 and the denominator is 7. So it basically says that if we split something into 7 parts and we take 2 parts of it in it, that is 2 over 7. So it basically means that two portions of a 7 portion. Or yes, so basically it means 2 out of 7 portions. And that's basically what fraction is. And then we have like fractions. Like fractions. So like fractions are basically fractions that has the same denominator. So basically the bottom number is the same, and that are like fractions. Okay? Fractions with the same denominator. Denominator. Cool. So like fractions are fractions with the same denominator. For example, we have 2/3 and 1/3 and 3/3, and they're all like fractions. They're all like fractions. So how about 2/5 and 1/5 and 4/5? They're also all like fractions. However, 2/3 and 1/5, they're not like fractions because their denominator are different. Alright? They are like fractions. So when the denominator is the same, or when fractions are like fractions, and when you're adding like fractions, you can just directly add the numerator. However, when you are adding fractions that are not like fractions, you had to make them like fractions before adding the numerators. And that's basically how you do fractions addition. So they're important for doing fractions addition. Okay, and let's look at a sample solution here. Yeah. Basically, they're like fractions are just fractions that has the same denominator, and like fractions are really useful for doing fraction addition. So let's just say, great job, the solution is correct. Solution is correct. And let's move on to our fourth problem now. So now, this question asks us, how does sine of pi equal to 0? Sine of pi equal to 0. So basically on our unit circle, again, let's draw a unit circle. And let's draw a circle over here. The center of the circle should lie on the origin. Okay, let me just redraw the axes to make it better, to make it more accurate. Nice, that's much better. Cool, it's very regular. Okay, so the center of the circle lies on the origin. Or I guess I should just not label the origin, because I'm going to draw the angle for you later, and it will be hard to do it if we label the origin. Okay, so the circle lays on the origin, and you start counting from the positive x-axis. So the angle starts counting counterclockwise from the positive x-axis, and pi radians is 180 degrees. So this is our pi radians, or 180 degrees, or 180 degrees, and this is our pi radians, or 180 degrees angle over here. So this is our angle. Okay, so here's our angle, and on the point here, when the angle is pi or 180 degrees, the value on the unit circle is, it's pi. Oh, sorry, it's -1, 0. So that's, let me just write it down on the outside of the circle. So it, oh, what happened? Okay, so on this point right over here, the x value is -1, and the y value is 0 on the point on the unit circle at where the angle is pi radians. And we know that on the unit, the cosine values and the y values are the sine values. So sine of pi is the y value, and this value is 0. And that is why sine of pi equals to 0. You could also explain it in terms of the sine function in the Cartesian plane, but we're just going to explain it in terms of the unit circle, because this is much more straightforward, in my opinion, compared to the graph. Or I guess I can quickly explain in terms of the sine graph. So consider the function f of x equal to sine x. And that function goes like this, and goes on and on forever. So that's, if we're only concerned with the positive side. So at the value x equal to pi, so here x is equal to pi. So let's do here. At on this point of the function, when x is equal to pi, the y value is 0. Okay, so we know that when x is equal to pi, when x is equal to pi on the function, f of x is equal to f of pi. So which is this point on the circle, which is 0. Okay, so that's how we know that's another way to know that sine of pi equals to 0. And that are the two main ways, or two most straightforward ways that I think to explain that why sine of pi is equal to 0. You can also just have like a table of values of all the common sine angles or cosine angles and tangent angles, and memorize it, thinking it through quickly using the unit circle or the sine curve. It's much easier, in my opinion. Especially if you're also taking physics, then it's very easy to think about the values of sine from the sine graph. Okay? And let's look at the sample solution. Yes, let's just say the solution is correct. Okay, and let's move on to our fifth problem. And here we're asked to find the exact value of sine of pi over 12. So we're asked to find sine of pi over 12. The first observation that you can make about sine of pi over 12 is that here we have the angle pi over 12 is not one of your special angles. So triangle. So what should you do? Well, in this case, the best way to do it is to try to write this angle in terms of one of the angles in the special triangle. So let me try to do it this way. So we know that the easiest way to do it is probably, so let's write it down. Let's write pi over 12 in terms of 4 pi over 12 minus 3 pi over 12. Because 4 pi over 12 minus 3 pi over 12 is pi over 12, so we can write it this way, and this angle still have the same value. Also, we know that 4 pi over 12, we can divide both the numerator and the denominator by 4 to simplify the fraction. And after this division, we're left with pi over 3. Fraction 3 pi over 12, we can divide both the numerator and the denominator by 3. And after simplifying the fraction, we're left with pi over 4. And here we can write pi over 12 in terms of pi over 3 minus pi over 4. Why do we want to do that? Because we know that for the sum and difference formula for trigonometry, for trig, we have that this. So this is a formula that you could either memorize or if it's given to you on your formula sheet, then you don't need to memorize it. But we know that by the sum and product formula for trigonometry, the sine of A minus B, where A is an angle and B is also an angle, is equal to sine of A cos of B minus cos of A sine of B. So this is one of the formulas for trigonometry. Okay. So in this case, so now for our function, we have sine of pi over 12 is equal to sine of pi over 3 minus pi over 4 because pi over 3 minus pi over 4 is equal to pi over 12. And then we just apply the sum and difference formula, and we have, let's write it down. So let's let A equal to pi over 3. B equal to, okay, let me make my writings more neat. Okay, so let's put it here like this. So let A equals to pi over 3, let B equals pi over 4, and then we just apply the formula, and we have sine of pi over 12 is equal to sine of pi over 3 cos of pi over 4 minus cos of pi over 3 sine of pi over 4. Alright, this is our formula. Next, let's use our special triangles to figure out the value of sine of pi over 3 and cos of pi over 4 and cos of pi over 3 and sine of pi over 4. So let me draw these two special triangles here. So here we have our first special triangle. Whoopsie. The hypotenuse is 2, it's not root 2. And here our second special triangle, where the hypotenuse this time is root 2. And here we have our angle pi over 4, and here we have our angle pi over 3. Okay, so let's write down, we need to know sine of pi over 3, cos of pi over 3, and our cos of pi over 4, sine of pi over 4. So we know that our cosine is adjacent over hypotenuse. So for the angle pi over 4, adjacent side is 1, hypotenuse is root 2, so we have 1 over root 2. Simplifying by multiplying both the numerator and the denominator by root 2, we get root 2 over 2. Similarly, for the sine of pi over 4, we have opposite, 1 over hypotenuse, root 2, so we have 1 over root 2. Simplifying, after simplifying, root 2 over 2. For the angle pi over 3, we have 3 3 is opposite over hypotenuse, which is root 3 over 2. For the angle cosine of pi over 3, we have adjacent over hypotenuse, which is 1/2. Okay, so now we have all of our values. Next, we just need to substitute it into the equation above. So again, we have sine of pi over 12 is equal to sine of pi over 3 minus pi over 4, and after you just need to plug the specific values of the sine of an angle and cos of an angle into the equation over here. So first we have sine of pi over 3, which is root 3 over 2, multiplied by cos of pi over 4, which is root 2 over 2. Then we have minus cos of pi over 3, which is 1/2, multiplied by sine of pi over 4, which is root 2 over 2. Alright, so for our next step, we just simplify this expression even further by multiplying the fractions. So first we have, on the numerator, we have root 3 times root 2, which is root 6. Root 6. On the denominator, we have 2 times 2, which is 4. And here on a second term multiplied together, on the numerator, we have 1 times root 2, which is root 2. On the denominator, we have 2 times 2, which is 4. So here we have root 6 minus root 2 over 4, and that is our final answer of sine of pi over 12. Alright? So let's check the sample solution. The sample solution has 2 root 2. Okay, so this is actually the same solution as us, but our solution is simplified and their solution is not. So let's just say, but they are the same value. So just to say your solution is not simplified, but they're asking us to find the exact value, so technically this is the exact value. So let's just say the solution is not simplified, but it's correct. And let's say the solution is correct. Alright, now let's move on to our next problem, which is which is the 6th problem for today. So here let's move on to our 6th problem for today. Okay, let's zoom in a little bit. I can't really see the problem here. Let me see, I think there should be a minus sign. Yes, there's a minus sign in between, but it's of a really weird grayish color, so you can't really see it. Is this negative pi over 6? Yes, here is negative pi over 6. So the second term on the tangent function is negative pi over 6. Okay, so we want to simplify the expression cotangent of pi over 2 minus pi over 3 plus tangent of negative pi over 6 divided by 1 plus the tangent of pi over 3 multiplied by cotangent of pi over 2 minus pi over 6. Okay, this is what we want to simplify. Okay, so let's see what we need to do. So in order to simplify this expression, we need some information. So first we need to know that the cotangent of an angle, so the cotangent of an angle is equal to 1 divided by the tangent of an angle. So here our cotangent is pi over 2 minus pi over 3. That is equal to 1 divided by the tangent of pi over 2 minus pi over 3. Next, let's simplify by subtracting the angles. You could apply the sum and difference formula for trigonometry, but it's easier to just simplify the angles by finding the common denominator of the fractions. So here we know that pi over 2 is the same as 3 pi over 6 if we try to multiply both numerator and the denominator by 3. And then, similarly, pi over 3 is the same as 2 pi over 6. So here we have 1 over the tangent of pi over 6. Okay? So this is our first equation. And then, similarly, for our cotangent of pi over 2 minus pi over 6, we have 1 over the tangent of pi over 6. And similarly as above, of pi over 2 minus pi over 6 is the same as 1 over the tangent of 3 pi over 6 minus pi over 6, which is the same as 1 over the tangent of which is pi over 3. Okay? So we need to know, now we need to find the exact value of tangent of pi over 3, tangent of negative pi over 6, and the tangent of pi over 6, which means that we will need our special triangle right over here. So we need the 30, 60, and 90 degrees special triangle. This is 30 degrees. This is 60 degrees. Oh, I'm sorry. It's the opposite. So this is our 30 degrees, and this is our 60 degrees. This is our 90 degrees right angle, and these are the 3 sides. We know that the tangent of pi over 3, so it's the 60 degrees angle. Okay, so if we're doing them in radians, let me just write everything in radians. So this is our pi over 3. Here's our pi over 6. So for tangent of pi over 3, tangent is opposite over adjacent, which is root 3 over 1, which is root 3. And then we have the tangent of pi over 6, which is equals to opposite over adjacent. Or sorry, which is opposite over adjacent, but it's for the angle pi over 6. So it's opposite over adjacent, which is 1 over root 3. If you multiply both the numerator and the denominator by root 3, you are left with root 3 over 3 as a simplified version for tangent of pi over 6. Then we need to also know the tangent of negative pi over 6. For the tangent of negative pi over 6, we know that the negative pi over 6 is in the 4th quadrant. So let me just draw the unit circle over here. So for the angle of negative pi over 6 is in the 4th quadrant, where the x values is positive and the y values is negative. So the tangent of negative pi over 3 is negative root 3 over 3. Oh, sorry, the tangent of negative pi over 6 is negative root 3 over 3. Okay? Now we have all the values. So we just need to plug in the values into our expression right over here. So let me just copy down the expression to like below so that we can see it. So here is our expression. And we know from above that the cotangent of pi over 2 minus pi over 6 is equal to 1 over the tangent of pi over 3. Sorry, from here, first we need to know the cotangent of pi over 2 minus pi over 3, which is 1 over the tangent of pi over 6. So this is 1 over the tangent of pi over 6 plus the tangent of negative pi over 6. Then we have 1 plus the tangent of pi over 3 times the cotangent of pi over 2 minus pi over 6. And we know that the cotangent of pi over 2 minus pi over 6 is 1 over the tangent of pi over 3. So here on the numerator, we have 1 over the tangent of pi over 6. And tangent of pi over 6 is root 3 over 3. So it's root 3 over 3. And here on the denominator, and then on the numerator we have plus tangent of negative pi over 6, which is negative root 3 over 3. So it's negative root 3 over 3. And let's just drop the minus sign. Perfect. And here on the denominator, we just have 2 because tangent of pi over 3 times 1 over tangent of pi over 3 is just 1, and 1 plus 1 is 2. And on the numerator, we have 3 over root 3 minus root 3 over 3 over 2. And let's do some further simplification. So what we also have is that if we multiply this, both the numerator and the denominator, by root 3, for this number we got 3 root 3 over 3 minus root 3 over 3 over 2. Then we have 2 over root 3, or sorry, 2 root 3 over 3, 2 root 3 over 3 on numerator, and we have 2 on denominator, which is left us with root 3 over 3. And that is the final solution for this problem. Okay, now let's look at our sample solution. So our sample solution says that they simplify it to this way, but it says fully simplify. So if they want, yes, they did fully simplify. Perfect. So we have 1 over root 3, which is root 3 over 3. They didn't quite fully simplify it because technically, if you have radicals on the denominator, it's not simplified because radicals have to be on the numerator for like fractions. But I think this is good enough because it's kind of in the trig context. So I guess this could pass. So let's just say it's correct, although can be simplified even further for radicals. Okay, and let's just say the solution is correct. Okay, now I think I went a lot over time, but I guess that's all right. And this concludes our live stream for today. We covered 6 problems, which is pretty good. And thanks for coming. I hope you enjoyed the OneClass live stream. And if you really like our videos, please hit subscribe. I hope I could see you again in the future. Bye-bye. Thank you.